Dear students, welcome to my YouTube channel. Today we are going to talk about representation of transfer function in MATLAB software. So let's start the video. So you already know the transfer function is nothing but the ratio between the Laplace transform of the output to the Laplace transform of the input when initial conditions are 0. Basically, the time domain analysis, frequency domain analysis, and the stability of the system can be analyzed easily when the model of the system is represented in the form of transfer function. So let us consider one polynomial. So here we consider the polynomial as a gs equal to numerator polynomial in s and denominator polynomial in s. Okay. So the above transfer function can be represented in the MATLAB if the coefficient of the numerator as well as the denominator are known. So let's consider one transfer function. So here we are denoted the transfer function as the gs equal to ns by ds. Ns is nothing but the numerator and ds the denominator. So here you can see we represented the numerator polynomial as bm s to the power m plus bm minus 1 s to the power m minus 1 up to the power b up to b naught. Similarly for the denominator here you can see. So here you can see bm minus 1 up to b1 b naught are nothing but the coefficient of the numerator. Similarly an minus 1 a naught are the coefficient of the denominator. Okay, so in the MATLAB the transfer function can be represented by using this syntax. So here n is nothing but the numerator. So first of all you have to represent the coefficient of the numerator of the polynomial. So here you can see this is the coefficient of the numerator, that is the bm minus 1 up to b naught. Similarly you have to represent the coefficient of the denominator. So d equal to an minus 1 dot dot up to a naught, and then you have to remember this command, that is the transfer function, that is the tf. So just write the tf in bracket n comma d. N comma means n is nothing but the numerator coefficient and d is the denominator coefficient, and then you can easily find the transfer function of the system. Okay, similarly if you want the coefficient from the transfer function in MATLAB, so you have to use the syntax, that is the tf data. Okay, so you have to represent just like this, tf data bracket system transfer function and v. So v is nothing but the variable. Okay, and it gives the return, it returns the values as a row vector. Well, let's take one example. So here you can see this is one of the transfer function, that is the s plus 2 divided by s cube plus 10 square plus 15s plus 150. So first of all you have to represent the coefficient of the numerator as well as the denominator. Then you have to write the command, that is the transfer function, that is the tf in bracket n comma d. Then if you want the coefficient from the transfer function, just you have to write this command, that is the tf data in bracket the transfer function and the variable v. Okay, now we are going to MATLAB and try to implement the example number 1. Okay, so first I am writing the numerator coefficient. So here I represent the numerator as a n, so it will be 1 0. Then representing the denominator of the transfer function. So denominator coefficients are 1, 10, 15 and 150. Then you have to write the command, that is the tf short form. So if you have just remember the transfer function just like its short form, that tf, and write the value of n comma d. Okay, just run this program. So here you can see this is the transfer function, that is s plus 2 divided by s cube plus 10 square plus 15s plus 150. Okay, so just you have to remember one command, that is the df. Now if you want the coefficient of the numerator and denominator from this transfer function, just you have to write that I just represent the numerator as a n1 and the denominator as a d1, and just write tf data. In bracket you have to write system, that is sys, here we define as a sys, and comma variable v. Okay, now I am running the program. So here you can see the numerator coefficient are 0, 0, 1, 2, and the denominator coefficient are 1, 10, 15, 150. So initially we are just writing the coefficient, then we got the transfer function, and then from the transfer function we can also get the coefficient by using this command, that is the tf data. Now we are taking our second example. So we are taking this example, that is the 2s cube plus 5s square plus 3s plus 6 divided by s cube plus 6s square plus 11s plus 6. Okay, so here you have to just replace the numerator coefficient. So here the numerator coefficients are 2, 5, 3 and 6, and for the denominator coefficient it will be the 1, 6, 11 and 6. Okay, so and the rest are the same. So just I'm running the program. So here you can see this is the transfer function, and this is their coefficient of the numerator as well as the denominator. So it is very simple, just you have to remember the transfer function and tf data. So in the next class we take how we can find poles and zeros in a transfer function by using the MATLAB, and also we see how we can plot pole and zero by using the MATLAB command. Thank you.